All right. 3.5. Perform basic matrix operations. Have y'all ever done anything with a matrix before? Nope. No. Okay. It might ring a bell when we do some stuff here. All right. I can't decide what color. This one. Okay. So a matrix is a rectangular arrangement of numbers in rows and columns. Okay, its dimensions are m rows by n columns. Okay, m by n. So that's how we refer to a matrix. This is what we call them. We would say, like, it's a 2 by 2 matrix, it's a 3 by 2, it's a 4 by 4. Okay, things like that. Okay, we say elements, okay, are the numbers in a matrix. Okay, so I'm going to draw you a quick example of what one looks like just so you can see it. Okay, we also label matrices. Okay, matrices is the plural of a matrix. Okay, we label them with capital letters, okay, when we're referring to them. So we're just going to say that this particular one, it's going to have 2 rows and 3 columns, so it's going to be a 2 by 3 matrix. Okay, now when I put these numbers in, okay, it doesn't matter right now, I'm just giving random numbers. Okay, they don't touch. Okay, they're not being added inside, they're not being subtracted. Each thing is an individual element. Okay, so this is what's in row 1, column 1. This is row 1, column 2, row 1, column 3, and so on and so forth. Down here, row 2, column 1, and so we can label them that way as well. Okay, just so that you have seen it. Okay, 3 columns, 2 rows. Okay, for a matrix to be equal, okay, the dimensions have to be the same. And the elements in corresponding positions are equal. Okay, so if I have a matrix that is, I'm just going to do something small. Okay, if I have this is equal to okay, then just looking at this, okay, the dimensions are the same. These are both 2 by 2. Okay, that one I just wrote the wrong thing there. Okay, meaning that x would be equal to -2 and y would be equal to 1. Okay, that's all it means for them to be equal. All right, I'm going to give a couple quick little properties here, / how to do stuff, and then we'll be done. I'm going to go to a new page to do that, though. Anybody still need this one? Okay. We're good? Okay. Alright, so adding matrices. Okay, so if I have a matrix A, B, C, D plus a matrix E, F, G, H, okay, this would still be a 2 by 2 matrix, okay? We would do A plus E, B plus F, C plus G, and D plus H. Okay, so we still, first row, first column added together, first row, second column added together, okay, and so on and so forth. Okay, we're going to do the same thing for subtracting. Okay, so I'm going to have the same matrices here. I'm just going to have them being subtracted. So now I'm going to have A minus E, B minus F, C minus G, and D minus H. Okay, the same thing is not true for multiplying them though. Okay, multiplying is different. Okay, however, we can multiply an individual matrix by a single number. Okay, and that is called scalar multiplication. And this is a real number multiplied by a matrix. Okay, so just so you can see what that would be like. If I had 2 times A, B, C, D, I would get 2A, 2B, 2C, and 2D. Okay, so that just multiplies through. Okay, but like I said, multiplying 2 matrices together does not work the same way. Okay, it's different. I'm pretty sure it has a whole section all to itself. Alright, and then the last thing here is just going to be some properties of matrix operations, which are going to look similar to properties that you've seen before. Okay, we're going to let A, B, and C, okay, all labeling as each of them are an individual matrix. Okay, so the matrices with the same dimensions. And K be a scalar. Okay, meaning just a number like 2 up here. Okay, we have the associative property of addition. Okay, this is just going to be, if I can write correctly, A plus B plus C is equal to A plus B plus C. So this is just showing you that it doesn't matter which order you add them together, you're going to get the same answer. Then we have the commutative property of addition, okay, which is just going to say basically A plus B is equal to B plus A, so it doesn't matter which one comes first. If they're being added, they are still equal. Okay, and then the distributive property, I'm just going to put these all together and I'll just use plus or minus. Okay, if I have K, so a scalar times A plus B, so a scalar times 2 matrices being added together. Okay, I have K times A, or sorry, this is plus or minus, and then plus or minus k times b. Okay, so I can just multiply the scalar by each matrix and then add the stuff together just like when we normally do distributive stuff. Okay, and that's all we're going to do with that for now.